having me over in Colombia. First time I'm speaking here. I'm going to try and be very synthetic. I'm just going to talk about one project today. This notion of the river, it was a long discussion with Gavin, this notion of the river, the urban river in tropical countries becoming a ledge, a sort of urban ledge, which I sort of like. I think it works well. The work I'm showing you is a combined work of doctoral students, both engineers, environmental engineers, planners, and landscape architects, as well as master's students in architecture from the ETH. The model and the design you see here is actually work done by architecture students. The specificity of the ETH since I've been here, I've been there for 15 years, is that I finally succeeded after 5 years of negotiation with the faculty that we teach design studios to architects. We don't have a specific degree, there's just one degree in the ETH, but we're able to input these studios, and it's been very interesting because a lot of young architects have trained in these different dimensions and have finally felt rather comfortable with them to the point that they actually win competitions against competing landscape architects, etc. I believe in a way in the hybridization of these fields rather than the separation. But that's a long debate, and I don't think the purpose of my talk today is to go into that kind of polemic. All right, so I will start by explaining what the Future Cities Laboratory is at ETH. We have a variety of projects in Africa, Southeast Asia, where we really try to transfer methods and approaches in design to completely different environments. So in a way, what we did is we brought in this sort of landscape modeling and visualizing technology from Zurich to Singapore, but chose Jakarta because basically Jakarta, at least from the environmentalist or environmental point of view, is considered like one of the major black holes on the planet. It's beyond description. The city is sinking 20 centimeters a year because of groundwater being pumped, the whole city and infrastructure. There's no clean water being distributed to the city. There's no sewage water treatment, and roughly 500 tons of rubbish a day gets thrown in the rivers. So it's an extreme case in point, and what's interesting is Indonesia is actually a rich country, and we believe that it could very easily clean its act up. So that's why we chose that place. I won't go over all the names. These are the doctoral researchers from four continents that have come together, both environmental engineers and landscape architects and planners, to work together on this particular case of the Ciliwung River in Jakarta. The models, which were drawn actually by engineers, this is not really typically the sort of representation I'm inclined to show, but what it does show is this sort of complexity between the rural side, you see to the left, the urban side to the right, and how this whole water cycle, which is both river and groundwater cycle, gets affected by the way things grow. What's extraordinary about Indonesia, it's a city that Jakarta is a city that I visited for the first time in 1982. There were barely 3 million people. I come back 25 years later, there are 30 million people living there. So tenfold growth in less than a quarter century without any planning. There's not even one plan done. It's just spontaneous, in a way, if I can say, capitalistic growth. You know, you have a parcel, if you have half a hectare, you can pack on 40 stories, pump the groundwater, etc., etc. So it's a phenomenal thing happening where basically all the books and all the rules that we've learned in our schools can be thrown out the window, and you just have to witness this thing going on. Right? Very complicated situation. I won't go into all the questions, but we always try to integrate 3 scales to our method. We'll focus mostly on the smaller scale. There's the whole water catchment. That is to say, the policy used along a sort of land use policy affects then completely the reaction of the river corridor itself, and then 3 specific sites that have been chosen. Our aims was to really be able to use the Ciliwung River as a model for many Southeast Asian tropical countries, whether it's the Philippines, whether it's Vietnam, whether it's Burma, Malaysia, the idea is really, I'm a little bit worried it's blinking. I hope my computer won't die on me. And the idea is to take it as a test study to really try and work through iterative processes. What I mean by that is the designers, the architectural designers, were actually put through testing by hydrologists to make sure that their designs were actually operational. We'll be seeing that a little bit later today. We worked a lot also with local schools, the Institute of Technology in Bandung, the University of Indonesia, I won't name everything, but government institutions as well as NGOs. So we were really involved also very much on the local scale. I think the catchword here is participatory, but actually it was more getting feedback and really trying to understand basically what the cultural practices and needs were within that particular context. This is the sort of technology we brought in. This is actually a CNC mirrored model that you see on the left, showing the entire catchment of the Ciliwung. It's roughly 100 kilometers. Oh dear. This one seems to work. That is precisely the base that we use, sort of information base that we use, in which to model our solution, in which to come in and actually develop a specific methodology of landscape design. What was interesting with the Ciliwung, which is also the river that flows really in the heart of Jakarta through the oldest part of Batavia, the old colonial capital, is that they had retained the upland area for a big dam. The flood has been a really major problem in Jakarta for many years. Last year, again, it flooded 3 times. They evacuated hundreds of thousands of people. Dozens of people got killed. So they were always planning to build a dam. And what's interesting is you have this sort of idyllic rice field landscape up there. You almost feel like you're in Bali, even though you're right next to Jakarta. Here we are with our students and some fellow colleagues, students from the University of Indonesia. Here we are in Bandung teaching Indonesians how to fly some of our little drones that allow us to get information. There's another problem that we had on site. It's not just that we wanted to show off Swiss drones to Indonesians, is that it was almost impossible to get any kind of data on site without probably the use of very high bribes and no guarantee whatsoever that this one's dying also. I'll move out of the way. There's no guarantee of the validity of the data whatsoever. So we deployed these drones in order to glean data. Here are some of my team mates from Zurich in the field in Chiawi, looking at the drone flying around. It's a little glider, very simple technology that can be operated with an iPhone or a laptop. And these are the models. I mean, I'm showing this picture, but they're actually 3-dimensional models of the terrain. And what's really interesting with these point cloud models that we developed is they're accurate in the vertical, which is really important when you simulate flood. They're accurate within 10 centimeters in the vertical, which allows you to have extremely precise data about a variety of sites. So here you see a compilation of the three sites. This is Chiawi, this is Tanjung Barat, which is the suburban site, and this is the informal settlement of Kampung Melayu that ends up, oh, you changed slides? Okay. Is that by chance, or is it being planned?
I'm not sure.
Maybe they're reacting to Swiss technology and straight away. But anyway, the informal settlement of Kampung Melayu, Gavin, you know that. I always have miraculous disasters with computers. It just happens. What's really interesting with this technology is it really gives you very precise information on the natural system going through, but also on the settlement itself. So that is the kind of technology that we transfer directly both to Singaporean students and Indonesian students, and it has become really, in a way, a recognized way of working on the site. We did it in all legality. We even have the Indonesian military coming in and giving us our reference points. I don't know if you know how it works, but you get very precise geographically positioned points on an area done by the military, and then you rivet. It's like riveting that model down. You snap it down so that then your point clouds are actually perfectly georeferenced for the rest of the territory. And I think the real revolution, because I was trained in environmental planning in the late 70s, early 80s, and it was very flat, two-dimensional. Then there was the mesh. You couldn't even work with that. There was a non-dialogue between environmental planners and architects and designers because the tools themselves were incapable of really working together. What's really interesting here is with the point cloud technology, you can actually embed design within these models. You embed your design within a geographic reality. That is to say, in a floodplain, it's rather useful to know whether your living room is going to be in 1 meter of water or 3 meters of water. And therefore, I think it's really worth developing. The other thing that I thought was interesting is I have one doctoral student, Irvin Lind, that has tweaked or tickled or pushed the point cloud to the point of designing the point clouds. Here he's building a dam across Chiawi, and with the hydraulic engineer, this is not Photoshop, he simulates a flood event and the retention capacity. And I thought that was really interesting in the discussion that we've been having together in his dissertation is, well, what is the actual limit of design? You know, how far, if you have a whole watershed and you create a series of dams like this simulating really the physical effect of a flood, is that design, is that planning? How do you interpret the information? Who do you give those skills to? Who do you trust? How do you develop those skills? So I think that was really opening a very interesting range of questions. And of course, when you see Kampung Melayu, the river, we coined it, we did a couple of articles on the plastic river. We did probes. Again, it's one of these rivers that gets hundreds of tons of rubbish thrown into it every week. We're talking about a plastic lasagna. The bed is almost 20 to 25 feet deep in plastic, and the rubbish, the liquid rubbish, just rolls over it and accumulates. And there's very little work being done, and I'm saying that without joking, on, for instance, plastic sedimentation. You know, most hydrologists get trained classically in, you know, the normal thing. You go from stones to gravel to sand to clay to silt, but no one's working on plastic sedimentation. You know, that's something that's happening, you know, from Nigeria all the way to Indonesia. It's all over the place. So I think that we're really addressing issues there that are central to the field and where we have to start understanding what the mechanical, physical properties of the things are. So this is just a typical river landscape, barely 50 kilometers downstream from Chiawi, the first rice field site that we showed you. Why does that happen? It's happening because of economic reasons. The poorest people, the renters, live in shacks there. The shacks get washed away every year. Some people get killed. I don't think that we can really glorify that situation. We obviously want to relocate or locate the people within the village, of course, where they are. But at the same time, we cannot just contemplate the situation and just say it's making great photographs, great pictures, and we think it should stay that way. We have to act on it. Effluents too are beyond description. We have a doctoral student just working on contamination. I'm not going to go extensively into that problem, but it does concern us. You know, none of the houses have any kind of sewage. Everything goes out. The same with industry. Industry came in and they could spill anything they wanted into this river. The classification of the water here is beyond any kind of normative category that you can imagine. Here are some of our doctoral students probing the plastic lasagna. This is in the dry season. We're probing into the riverbed to figure out how deep this plastification is occurring. Monitoring groundwater too with the students over the years. There's an expedition just going down in a cheap dinghy down the Ciliwung to inspect. And some of our students, these are mostly Singaporean students, trying to draw sections through the slum area of Jakarta. So those were the first probes. And then finally, we were able to develop at the level of the whole watershed, and within certain areas, we were able to really start gleaning point cloud information and building up partially a model. We have not reached completion of that model, but we're actually step by step getting into very high levels of precision. Just to show you one neighborhood, this is actually a point cloud model we did with the help, again, of the Indonesian military. You have little programs in Autodesk that allow you to work in very local point cloud information. You can just simply embed into that model. So this is just a point clouded slum of Jakarta. And you say, well, so what? What's the use of that? Well, if you really want to monitor flood phenomena, friction, and all those elements, It's really important to get the grain of what you're working with. So the applications are multiple. They're very dry, you could say boring engineering work. Here's a study on contamination at a local scale, but also at a much bigger scale. And then you have these incredible point cloud models. When I say incredible, they're very difficult. They were actually, it took a while to get them triangulated correctly, at least in the slum area, simply because we were unable to touch ground. There's so much roof that you never really touch ground. It becomes very difficult to sort of rivet and triangulate your space into flat terrain. But just to show the level of precision, this sort of view here again, you see the main roads and the slums here. It's just this little piece of the model here that you see magnified, right? And I also find, in a way, in terms of the sort of graphic fascination, or the fact that it is actually a relief, I'd say a bas-relief, maybe it's an old-fashioned way of saying it. You know, we were all trained in urban design doing noddy plans and everything. This is a point cloud plan of a contemporary slum, and where you see really very, very precisely almost every human facet sort of there, sort of compiled together. And it is actually a three-dimensional model you're looking at, not just a picture. So this is the model. This is a very heavy file. It's probably why it took 8 hours to transfer on the internet. And if you really look at the edge, it's a sectional edge, and you could actually cut 100 slices through that and generate all the transects you like in any direction. And that's very useful because it allows you both to really observe maybe physical phenomena like flood, but also to implant new projects. You can actually very easily embed a Rhino model, which now has a point cloud application, into that and test it. You can redraw the riverbed, that's what I'm going to show you. And obviously, asking that to architects, you can say, well, that has nothing to do with architecture, redrawing a riverbed. But then you may ask yourself the question, well, then who draws that? And for what purpose? So I think those are really interesting issues to look at. Here's a demonstration of the water contamination. That's a flood. That's the flood event of 2013. It's not photoshopped. It's actually just in real time showing the effect of that wave of water coming through the urban fabric and actually filling up a sort of, in a way, sort of giant urban bathtub, which ends up being 8 meters deep underwater in certain parts of the valley, the depression. Last year, there were at least 15 people killed in that event. I mean, it's not just a light thing. And I'm not even talking about the diseases and the contamination that happens at the same time. Here's also the mapping within that same model of contamination by engineers. So what I'm saying is it's interesting that we have a base which can be both used as a basic design tool, but also as a simulation tool for a variety of tasks. You could also simulate airflow, temperature in these models, etc., etc. And I think that this transfer of the technology of point cloud models to Southeast Asia has caught on because it really allows you to really look at things in a much more extensive way. Just as a demonstration, these are 2 aerial pictures of the flood that we're talking about. These are real pictures. I mean, real. It's a flyover showing the extent of water in the neighborhoods. And this is taking our model with the flood simulation, done at the same rate, roughly, comparing, right? I think that's really where it becomes interesting, that you're able to go into these critical tests in order to implement and to refine things. Obviously, these models have exerted a certain fascination on people. We've exhibited in Singapore extensively. But the reality of the terrain, the reality of those floods is something completely different. It's not just show, it's actually very mucky, very smelly, and there's nothing really that great about it. It's something that people have to deal with on a regular basis. The poorest people have to run away each time. Some people stay on and just clean their living room. I don't know how many times this old man has done that in the last 10 years. And people survive there, obviously, and the reason why they stay there is it's because it's a very central location in the city. There are jobs, there's an informal economy, there are a whole bunch of reasons to stay there. Most people living there would rather be flooded than move. But at the same time, I don't think that's enough of a reason to just leave things as status quo. We could keep people there in a different way, different manner. This is Derek Fulmer. He's an ecosystem service specialist. He did interviews. He even had to smoke those strange cigarettes in Indonesia to get together with the folk, and started asking people about how they used the river, how they used it. And that was really important too, getting the feedback from the base, because they're all very scared. The main fear they have is getting exported 50 kilometers out in some sort of camp. You know, that's the last thing you'd want to do. And in the inquiry, he did these maps, where they're very planary maps, but he shows where the local population that discards solid waste directly in the river, and then if you jump directly to, well, the cemetery use is also another thing, but then you look at recreation, it overlaps with this, you know. So you get into very contradictory information that sort of overlap. You realize that the river, for a very long time, it used to be the main road in Indonesia before even colonial times, has been used and misused and in a way abused. And I think that it's precisely this understanding of the relationship of a city or a population to its river and this lack of respect which becomes a critical question. Here again, some of our campaigns going down the very mucky Ciliwung River, looking at the detritus. I'm not going to go too long on that. And then the local kids jumping into water, which you yourself, you probably wouldn't survive jumping in it once. You'd probably end up in hospital because of the incredible level of contamination. It's both chemical and organic. These are the toilets. You actually have to pay to use the toilets on this river. The river is a resource. And these are again these Autodesk models of some of those floating toilets, which we've embedded in the model. I'm just showing you one thing, which really shows you how you can go from really the territorial scale of that point cloud model showing the volcano all the way to the Sea of Java, down to that scale. It's very unusual to have a system that allows you to go from the absolute micro scale of a slum, or a house, or a garden, or just the ledge of a house, for instance, all the way to the territory. Without any interruption. I think that's what's fascinating. We developed ingenious techniques to measure the river profile, what you call bathymetry, by using Garmin devices and little fisherman's probes, little $5 probes that give you the depth. And we were able then to carve into the point cloud model a sort of normal, what would be a normal bed of a river within the slum, right? It's almost like surgery. Then we looked more at the flood, the major flood problem, and determined actually that the zone was much wider. The flood area is a much broader phenomenon. And in a way, theoretically speaking, if we were really responsible, we should determine the ledge, or the edge, or the confines of the city to the edge of the flooding phenomenon. And if any new housing or rebuilt housing were to come there, it would have to react to flooding as a component in the program. And that's basically what we gave the students in Zurich to work on. They actually did field trips to Indonesia. They met Indonesian and Singaporean students there. And then they worked with Skype and all that with our doctoral students from Singapore back in Zurich in order to develop their designs. And this is what I was talking about. This is the normal situation, showing you a normal flow, a minor flood, and a major flood. It shows you this is the situation today. And here you have four design projects done by master students in architecture that will run through these phenomena by our environmental engineers, our doctoral students. And obviously some projects came out fairly resilient as compared to others. And obviously that created a huge depression in the studio because some students that worked day and night doing these super designs ended up being really condemned in a way at the end. So we all gave them good marks. That wasn't a problem. We really explained to them that it's an iterative, it's something that you have to go through to then test again. And I'll show you some of the designs that actually didn't really work that well. These are the analysis that they did. These are the housings that they developed, the housings where we told them you have to recover rainwater, store the water, treat your sewage in an urban block, keep your garbage to yourself, maintain the river area clean. I mean, we were starting to push in a way through design sort of policies that were discussed with NGOs and local people. And this is one of the models that actually failed because they were fascinated by these sort of Isfahan-like footbridges across. And these footbridges that are actually weirs, stepped weirs, would generate catastrophic lateral floods. You know, it's a beautiful design, it just doesn't work. But the work is rather interesting. This is a three-dimensional model. This is not Photoshop, with roughly 20,000 electronic trees here. And the gray buildings here are actually the new buildings proposed by these architecture students. They're on stilts. They're actually standing in the floodplain. So they had to design three things. They had to design the river profile, the landscape, reacting to that, and the new urban tissue along the river. And I don't see why this sort of domain should be simply confined to civil engineers and why architects should shun away from that. On the contrary, I think that they should be really pushing for such initiatives in those cities. These are close-up views of those models. We added the people in it, but the rest of what you're seeing is actually just a close-up view of that model. Productive landscapes, foodscapes along the river, really trying to show that with this dimension then, you can create a completely different kind of environment. And in a way, if you really look at the situation in Jakarta, here you see how you can comment on the style of the buildings that probably look a little bit too Swiss for Jakarta, but they're on stilts. The whole physical logic, and this is a model, as I say, you could actually cut through this whole cake all along the design river corridor, and it would actually show the real reference to terrain. Again, that's the project that failed, the test. But what I like about that image is that it actually shows a very extensive park system all the way to the Sea of Java. This notion, finally, that you could work in a very comprehensive, multi-skilled way at bringing in a much higher quality of life in the heart of that city. This is a picture, and this is one of the projects. It's another project that actually passed the test. This was done by actually a team of women architects that didn't want to do the bridges or the weirs, but actually simply created productive landscapes, nature parks, public areas, played on an alternating landscape, an alternating side, hard side, soft side, and that actually worked very well, also in terms of hydraulics. Here you see some of that's the nature park, kids. These are the giant papaya forests producing food. There's a real tradition of agriculture always being part of the village in Indonesia. You have to understand it's one of the oldest agricultural societies in the world. And again, the sections, I won't comment on the architecture, which is obviously very, very pristine and Swiss compared to what you usually see in Jakarta. But this profile here is, again, the result of this model. It's just cut through that model time and time again. So I'll go quickly through the sections, and then we had a final, more romantic group of students that said, we want to build the original village, the pre-colonial village back in the middle of the river. That one didn't do too well either in the testing, because obviously when you have whole trees and houses and furniture coming down the river in these major floods, then this thing clogs up, right? But we just let, because it's just a studio, it's a one-semester studio, we let students investigate those different solutions. There's nothing wrong also in failing that test and in creating those different visions. On the contrary, I think it opens up discussions and debate. So that's, again, part of that sort of very romantic return to sort of primeval nature in the heart of Jakarta, that were at all possible. What I find ironic with that team is they chose to fog up, which is the reality of Jakarta today, completely hazed up, fog up their project. The village that you just saw is in this sort of meander area, meander swamp. The resonance in the local population, the local press, and the local government has been very good with this vision. There are projects financed by the World Bank to build a huge seawall in Jakarta for $19 billion. The city's sinking. The Japanese are building concrete channels at great expense to try and put a lid on these flooding rivers. We believe that actually through a much softer and much more economical approach, we can achieve a much higher quality of living, quality of urban design by simply going into a much softer approach. We feel somehow that Indonesia is still a little bit stuck in sort of engineering modes of the 60s and 70s. You know, they haven't learnt yet from Seoul that got rid of its highway, etc., etc. I mean, I could cite quite a few examples that they should be informed about. We've been broadly exhibited, as Janette said, and we had a multidisciplinary team of teachers from Indonesia, Singapore, Switzerland, one happy family. And this is the last picture I can show you. It was also a very intense experience for the Swiss students especially. It was for all of them, the 22 that went there, the first time that they'd gone to Asia. And I must say, going from squeaky clean Zurich, being parachuted in to the Kampung Melayu slums of Jakarta overnight was quite a shock. But they actually managed through that, and I think that the learning curve was very, very high in that semester. So that's it. I've been a little bit long, I'm sorry, but I thank you for your attention.
Kevin, I forgot to ask you how you would like to do this. Should I sit here? And how much time would you like to take?
Just continue talking about one we can raise this if you like.
Sure, that's great. Oh, it's so nice to have sunlight. It's very rare.
Until 2, so we can just continue talking.
I was thinking that it's, especially since this is a lunchtime talk, there's something nicely informal about it. And I have some questions I want to ask you, but I actually think it would be great to let the conversation just flow out of questions that come from the room. So can we start in the room and see if anybody has any responses or questions, and then see where that takes us?
So I really appreciate the sort of depth of the detail and rigor with which you built the models. I work on a sort of informal settlement project with flood problems, and one of our biggest problems was having something accurate and usable, so it's really great to see that. Sort of two interrelated questions, one on the method and one on the sort of conceptual. In terms of the resiliency measures that you were testing at the end, I'm curious if those can be brought in sort of into the design process earlier on at all, or if they rely on a completed model. And then more conceptually, I'm wondering what resiliency means here and whether ideas of going beyond resiliency come into play, so sort of the notion of anti-fragility and sort of benefiting from the adverse condition rather than just recovering from it come into play at all.
Okay, so those are two very different questions, right?
Well, yeah, both tied to the idea of the resiliency, but sort of wondering how it can be used and then whether the concept can be extended.
No, I understand what you're saying. I mean, based on a semester, it's a bit torture to put the final designs of the students through the mill, right? But at the same time, if you understand the extent of the problem there, in reality, of course, and we're using the school, the studio, also to communicate things to the outside. It would be obvious that if the city were to adopt that, or if other regions were to adopt that, it would need to go through the loop several times, and it would probably require a studio to run for a whole year to really get that level. Because the problem is you can't, if you're going to calculate friction, you need to have the objects. So if you don't have the objects, then what are you calculating? And in a way, you have to have certain things in place in order to really be able to ascertain whether a thing is actually operating correctly or not. I mean, I'm absolutely not a hydrologist. I mean, I have colleagues that are environmental engineers and hydrologists, but it's been very interesting that if I can just flip around your question, the engineers are sort of asking to say, please give us form. Let us test your form. Just go ahead, give us forms. And I think that's the way I was a little bit explaining to the students. It's a bit also like an architectural design competition where you have 20 teams and finally just one goes through. It just happens. It's not fair. It's never fair. But at the same time, I think we have to accept this notion of the loop. And of course then, the team that did those wonderful weirs, I think they're a great idea. They probably would work in some other part of the world, probably in the deserts of Arizona, when it just runs once every 10 years, you know, create a lake all of a sudden, something like that. There you have to learn how to kill your darlings in a way. I mean, there's a moment where you have to let go because you're confronted to a force there that just is overwhelming. So, in a way, you're right, but it would have been difficult to test those projects earlier on, really.
I wonder too, just to piggyback on your question, I wonder if there are ever times in which you make a model, you do a design, and you start to realize that you didn't, in the first round, get the data that you wanted, and that the design gives you information about the kind of information you then need to gather next. I'm wondering if there might be a kind of back and forth cycle between an analysis and design.
I would say yes in the ideal situation. If you're in a country where if you're working, I didn't ask you where you were working. If you're in a country where it's rather easy to just fly drones around and go back and glean things, obviously we would have done that. I mean, it took us, it looks really easy there, but it took us 3 years just to get those point cloud models, which normally in Switzerland would take us a week, you know. So what I'm saying is, that's also the tricky part, you know. People see you coming through customs with these strange devices, and you know, it's a form of espionage in a way. So it's rather tricky. You can't also get students just to go out and do things in that lineal sort of way. So it's true, the way I packaged that presentation looks like everything's smooth and streamlined, and it's the absolute opposite. You know, there's a complete headache from beginning to end. Yes?
I wonder if, from the several proposals that you gathered, if there was a clear finding of how to keep the highest, what were the technologies that allowed to keep the highest densities of population in those areas. And I say that because I imagine that those areas are occupied because of they're close to jobs, and that may happen again. Mostly it is a territorial project. You have policing continues the river continuously, and at the same time, because I imagine that at large scale, if the densities that are provided are very slow, that would mean massive evictions along the river. I remember the case in Guanabara Bay, in one of the lakes in Sao Paulo, where the reconditioning of one of the lakes of Sao Paulo where people drink would require 500,000 people relocation. So there was not a perfect match between the ideal scenario and the best solution. And they had to come up with simply like best solutions for people not to have flooding and die, but not the ideal scenario. So were there findings on typological solutions that allowed for high densities of population while keeping the flooding?
Well, I think it's a very good question. If you know São Paulo, I mean, Tietê, I mean, is obviously there's real potential there too for improvement. But we won't go into that. But we just did, for the sake of students, we just said we're doubling the density. We're doubling. But what we were fighting a little bit against with these monoliths, which actually have been no problem, you know, these very deep parking lot blocks, shopping mall with towers on it, that's where the people died, you know. People died in their Mercedes on the 3rd floor underneath, because the river just came in. You know. It's rather uncomfortable. You come and do shopping, and then you get flooded, and you die. Right? So we believe, and there's huge pressure, there's huge speculation. I mean, you know how that works. We're in the center of town. If we clean it up, it's going to become prime real estate, right? But at the same time, if you look at the history of that site, or the history of that culture, you know, it went through Buddhism, you know, Cambodia was there. It was almost like Angkor Wat. I mean, there were very old cultures, and Islam, etc. The riverfront throughout those whole periods was the most noble site. It was where the guests would arrive. It was the road. That's where the chief was. That's where the temple was. It was respected. It was never sullied, never dirty, right? And then with the exploitation of the Dutch, and especially the sugarcane, they started throwing all their refuse there and created roads. They created roads, and the river became the backside of the city. Right? So why I'm going on this sort of parenthesis there is I'm saying the real question is, are we bringing back dignity to that neighborhood? I would tend to say yes. We doubled the population, said even the poorest population should have a shack or a shed or a workshop within that, and we provided examples of that, knowing full well that that is a very fragile proposal, right? It's a fragile proposal. But at the same time, this notion of doing 4 to 6 story walk-ups with the capacity to store rainwater at the block level, etc., we thought that it wasn't maybe the best option. I mean, we think that doubling the density is fairly high. It could obviously go much higher. I mean, if you know Jakarta, if you own 5,000 square meters, it's a bit like Sao Paulo, by the way. You can actually go up 40 stories, you know, and land your helicopter on it. You know, I mean, so those are issues we weren't able to totally tackle in the space of a semester. So programmatically, we really just doubled and said you have to widen the river, and the population that's being displaced is not deported, but kept locally. That's always what we communicated in our work, but it's just embryonic work. You know?
I think there are a couple of really amazing things that you're offering this part of the world in the project you showed. One of them is the visualizations that they're not used to probably seeing at that large scale, the simulation of sort of catastrophic events, but also what I think is really different, having sort of worked in this area of the world, is that they probably don't see design as being able to intervene on that really, really large scale, is what I found, especially at the government level. And you talked about that the growth that has happened in the last 25 years has been completely spontaneous and unguided by city planning. How do you think the government would see the ability of these tools to then start to guide the sort of next high velocity growth rates around the city? Or do you think the government would actually see this as a critical tool and be able to use it at the level of design and sort of city planning? Do they see like the intelligence of the system, and do you think they would use it?
Well, one would hope so. I mean, they just elected a new government there with Jokowi to actually quite a revolution in itself. It is the biggest Islamic democracy in the world, Indonesia. It's a very complicated place. I mean, I couldn't set up office there. I don't think that's the goal either. But I do think that those tools, at least at the university level, we've already presented that work to the governor. They know that we have those tools, etc. And the real question is how that can really be pushed further. I mean, I think we've transmitted a certain level of know-how with this lab, etc. But that very big scale thinking is complicated there, because what looks so easy is actually rather complicated even politically. You have different regions, different regional governments that don't even talk to each other, different languages. Sundanese is not Javanese. I mean, it's very, very complex stuff. The reason why we chose the Ciliwung is it's the only river that has gotten an extra territorial status. It's actually directly under the president of the country. So if it were to happen, it would have sort of a state authority. We had been advised, and that's why we've been very cautious until we had been advised not to contact the big politicians, to really solve things at the local, neighborhood level, informal level, before showing anything. Because anything that would be parachuted down, like the president coming in saying this is the picture, would be shot down because of skepsis and a lot of reasons. So it's a good question. I mean, I think they're convinced that that's what they need to do. They're also convinced that the river should become the new park system for that city. It would be a fantastic thing to have 13 green parks going through the city in that way. Whether they really find, the way Seoul did it in a way with, I can never pronounce that river, but it's a we're still miles away. I mean, we're in a society where the middle class, they've all of a sudden reached 50% of the population. 50% of the population has become middle class in Indonesia, which is a complete revolution. Whether they're ecologically conscious, I don't know. They're very much like we were in the late 50s, early 60s. We want everything new, we want to go fast. And we know we have a problem here, but it's not our concern. It's a little bit the problem.
It's interesting to me that in the last two questions, there's this question about the public and how your projects work with, basically define the public and then work with these publics that you are able to identify. And it seems like in both, in a lot of your work in Switzerland, you are at times, I think, commissioned by a transit authority or a government agency. At the same time that you also do participatory planning work.
Yeah.
I'm curious to understand the switch, to continue your question. I'm curious to know who you see as your client in many cases and how you negotiate your methods of participatory planning with the kind of funding structures that often come into play in projects like the ones that you've done in the Alps, for example.
Well, the laboratory that we have, and I share it with the engineering department, it's used very much for participatory information rounds and simulations, etc. So we're used to those loops. What's new in Indonesia is it's a completely different context. And obviously we came in with Singaporean financing and Swiss financing. We were never asked by the local government to come into Jakarta and stick our nose into this mess. You know? So we came completely from the outside, which has its advantages and disadvantages, in the sense that we were very free to maneuver and to develop those tools and actually to transmit them to local schools and younger people. But on the level of decision making, I don't think that we really push things far enough. And it would probably require a second project to really develop that level of skill in that context. In Switzerland, it's the democratic process and decision making is established with the ETH has been going on for decades, and it's just the techniques of visualization and these scaling tools that are new, but the processes are the same. You know, they remain fairly close to what they were, in the sense that people give their opinion. They usually are very critical about what we showed, so it's a very healthy, critical thing. Maybe Indonesia is rather uncritical, you know, in the sense that anything new, without really necessarily testing things.
It seems like to you, my understanding is that visualization for you plays a big role in allowing people to understand the possibilities of a design proposal and then start to kind of maneuver or change what those proposals might bring about.
Well, yeah, I think there's a real conceptual revolution there with these models. So that it's not Photoshop images, it's actually a whole model. And when you have that model at hand, you can actually walk people through it, show them things. If they ask questions, you can take them to their house, literally. They have their house and their shack in the model. So it's really very helpful in that respect, because the real problem, decision-making processes very often is how it's represented, you know. We're, of course, used to zoning plans, but when you show a zoning plan to the population, it's an extremely abstract, two-dimensional pattern. They can't identify physically with what they're seeing.
Are there other questions?
I just wanted to know more about freshwater resources for them, how they get freshwater. I don't know if you said that in this.
It's a business. In the slums, the slumlords have trucks that drive actually Ciliwung water. They go get the Ciliwung water upstream. They bring it down. They sell these big blue bottles. Hopefully, it's going to be solved sooner or later. You know, but it's extraordinary that there's no supply. For the time being, there's no supply. Each building pumps its water in the table. It's highly contaminated now because of this plastic. It's infiltrating the whole water table. I mean, I'm not going to go into all those details, but it's a very good question. That issue is really crying right now.
There's no governmental agencies in the country.
Oh, I'm sure there's a ministry, there are agencies, there are a lot of those things. But I mean, you know, it's difficult to really. You don't have the control. If you try to compare the institutions that we have in America, for instance, with those that you find in Indonesia, it just doesn't work at all the same level. Even the way decisions are being communicated and done. They're learning, sorry, I think it's going to come. I'm optimistic that within the next 10 years, they're really going to clean their up. It's a rich country now. And when I went there for the first time, I saw literally starving people. I haven't seen that. You know, I've seen poverty, but I haven't seen people really starving to death. There's no reason why Indonesia shouldn't be attacked like that. It's about time. And it's probably not our job as European professors to come in and tell the president of the country to clean its act up. It doesn't work that way. So that's why we've been transmitting things to schools, to local agencies, to really promote that from the bottom up. Did that answer your question somehow?
I wonder if we could take a step back slightly, and I would like to know a bit more about the kind of background of the technologies that you're using and how they're influencing your work. But I think at the school there is a wide interest in the way that information is measured and produced, and the way that that's influencing architectural practice. And I'm curious to hear a bit more about the production of these laser sensing technologies. Where were they produced? Who made them? What kinds of changes do you need to make to implement them within a spatial or architectural or planning context? What are the kind of terms of that technology that you have taken on?
Well, there's nothing new with point clouds. I mean, they've been around, especially in the digital world and in the design world. I think it was Greg Lynn and other people in the late 90s. There were whole debates on point clouds. I think the big shift now is the fact that they're actually geographically located. So it's one thing in the image and in the modeling thing. It's one thing, but having it geographically fixed, which allows you then to really simulate things, is another thing. So I'm not claiming that we've invented anything. I think that we've just transferred knowledge from the field of engineering, and we're bringing it slowly but surely into the field of design. And I tend to think that any design school, especially if you're going to address issues of flooding or coastal protection, I don't know what it is. You know, if you get a contract from the state of New Jersey to redesign 100 kilometers of coastal tract, what are the tools you can use? And who are you relying on? And I think the real problem or the real issue that I see is that we've conceded so much to civil engineers, and I have nothing against civil engineers except for the fact that they have very, very limited design skills and design sensitivities. I'd rather go back to a sort of combined architecture, engineering, landscape architecture profession that really masters both the technical issues and the design issues within one. And there I see the opportunity with these models that they're probably going to become very common within the next 10 years. I think each town will have its point cloud model. It just takes a couple of helicopter flights with a good LiDAR and you have that base. And then any of your proposals, your planners and designers will be embedded in that and tested, and people will come in, go into their house and look through their window in the model and tell you exactly what they think about what you're doing. So it's actually going to come from the other side. It's going to come at it, whether we're prepared or not to live with that. The reality and the efficiency of these models is going to come in, and it's going to test also the way we design, the way we represent things. Very often, I was trained in one of the worst periods of architecture, in the early 80s, with the whole postmodern thing, where we were always taught, with Prismacolor and a couple of facades, you could get away with murder. You could basically rebuild the world with a couple of crayon facades. We call them facadamists. But what I'm saying is that relativity, the fact that those models are cheap to make, relatively cheap to make, and really easy to use, because the technology is developing very quickly now. And then they're just going to ask you to bring in your Rhino model and import it. And inversely, I think if schools start teaching proactively, working with the geographic reality, working with the coastline and elevation points, understanding terrain, I use the word topology a lot, I think it can only benefit a school of design to go into that. And just to conclude, I don't see why we shouldn't let, why is it only engineers drawing a couple of sections to get billion-dollar contracts to work on coastal areas or rivers, and why we just wait until we get a commission to do the little shopping mall in the corner on the left-hand side? Or is that not our interest to work in those different scales? I think that's a big mistake right now, is this idea of closing ourselves into just the object and the doorknob. Of course, some of you may succeed redesigning doorknobs in your lifetime. I'm not saying that with irony, I'm just saying some of you may be very, very talented designers of doorknobs. But in general, the profession should be able to go from that scale into bigger territorial questions. Otherwise, we're going to completely missed the boat.
I think with the use of information as an analytic tool, there's often an assumption that more information is better, that higher resolution yields more information. Is there ever a time when you find, can I say this, to what degree do you think that more resolution or more information yields better interpretation or greater knowledge? To what extent do you think there might be an over-reliance on data as, let's say, a measurable source of knowledge or site knowledge?
You can filter point clouds. You can reduce it by 100. You can filter things. I mean, what I find interesting in point clouds is, of course, it's quantity. You're right. You're absolutely right. Even though it fits on the laptop, you can work with point clouds on the laptop. It's not like you need some supercomputer. You need the supercomputer to calculate the phenomenon. You know, when you're simulating a flood, then it has to go. At the ETH we have Brutus, so we get an hour of Brutus doing parallel computing, and we run the flood through it, right? That we can't do on a laptop. But the model itself is a fairly easy thing to maneuver with, and you can choose selectively what you want to do. You can get rid of the buildings, you can get rid of the trees, you can have just the trees, just the building. It's a very, very versatile tool. So I understand your question about the weight. I mean, this big data question that always comes back. I don't consider it big data. I think big data is your friendly Google. You all trust totally until now, right? That's big data. Big data is about everything and nothing. I mean, honestly speaking, I don't think we can be ostriches and just ignore this notion of going into a more complex geographic reality, of course with more information. It means also that you don't have to analyze every point of information in the model. I think that's the wrong way to look at it. I think it's much more a question that you have freedom of choice, of operation, of testing. You can simulate forest growth, you can simulate urban growth, you can do a variety of things in these models, which I think are very serious tools, you know, for future adaptation. We will use the word resilience now, it's the latest term that we use. We're not sustainable anymore, we're just resilient. And maybe at the end it'll just be resistant, resistant to change or to effects of nature. And I think the effects of nature are there. You know, I was just in Japan for a month, and they were fascinated by these concepts. But those are tools that they're definitely going to use and deploy in their own schools because of obvious reasons. Because they're dealing with physical forces, right? But they're beyond just stylistic issues or debates. I don't know if that answers your question.
Absolutely. I think to try it from a slightly different angle. So basically where I'm coming from is that I'm interested to test this boundary of where information gives us something and where it doesn't, and how we understand our reliance on it and where we need other tools. And I was fascinated to see your work today because, in fact, you didn't discuss the point cloud that much, actually. You talked as much about, say, ground truthing or about collaboration as much as you did the drones and the mapping process. And that, to me, sort of signals the way in which information can't be the only metric or the only kind of source. So to try to ask the question from a slightly different perspective, I'm curious how you see the difference between simulation, between real-world testing, and between scenario planning, which I guess in my definition would be different than simulation, because one isn't necessarily trying to project from current status what the future would hold, but one might sort of project possible futures and the way the design anticipates those. So if we see simulation as like, let's get the knowledge, let's get the information and see what we can, how our designs would respond to this knowledge, how then do real world testing or scenario planning sort of challenge that model?
That's a very difficult question to answer there. I mean, I agree with what you're saying. I mean, obviously you shouldn't take those pictures as a finished product, right? Even though they were simulated. We did develop scenarios. We probably didn't develop enough scenarios. We probably should have had a high-rise scenario compared to a mid-rise scenario compared to a nothing changes scenario. I mean, but at the same time, and maybe if we'd had time to run that parallel computing, we ran the flood through the existing point cloud fabric. You saw the result. and you could probably adapt a variety of interpretations based on that. The reason why I didn't really mention point cloud that much is it was such a headache getting it together there that I don't want to mention it again. But we could never have worked in this way without that base. That's all I'm saying. I mean, you need that base. You need that even to do the scenarios. You need to be able to test. Because it becomes, I mean, I always come back to that one word, you have to be physical in the world. You know, I mean, we've gone into very virtual realities, very, very two-dimensional realities. I think a lot of the programs, I'm extremely critical of Esri, for instance, in City Engine, that only works on flat white paper and just mushrooms. You can mushroom Venice or the pyramids of Egypt or I don't know what, Manhattan in the desert. You can do anything you want in 3 days, but it's not reacting to terrain. It's not reacting to the reality of a physical embodiment of reality. And I think that's what we should be training schools in. You know, in a way, I know that the schools of environmental design coming from Berkeley, they really failed in the 50s, in the 60s and 70s. But there's no reason why one shouldn't try to turn back to this notion of bringing all those different components and skills together. So, I don't know about, you know, in a way, this absence of scenarios there. I could have shown you with Adrien Perregame, who works a lot in ecosystem services. We did develop a whole bunch of scenarios, and also a much broader question is where we were saying, well, the river doesn't only affect the local people living there, it actually affects the whole neighborhood. The park can become a resource. People were even saying they would pay to have a park there. Even poor people were saying they would be willing to pay to have that service provided. So I've only scratched the surface there, but I think that well, what's interesting, once you have a much bigger neighborhood scale, like these big models that I showed you, is you can start working really at a variety of scales. And I think it's that gymnastic that I would encourage in schools.
Do I see? Shall we try both at the same time and see what comes? So let's start with you.
Right, it's great that you mentioned Google earlier, talking about big data. I just wonder, in the sort of scenario of internet nowadays, there's different agencies really digging into the big data for different purposes, for exploitation and commercial success. And what do you think the possibilities you are transforming reality into big data, and what kind of different agencies, what possibilities could be in the future, what are dangers?
Well, when we arrived in Jakarta, we thought that Google was going to save us, right? So we went straight to Google, right? And it was very useful to find your way in this labyrinth. You could map your way through, and actually organizing students, and actually even getting the drones to run on a Google map. We were able to work a lot with Google. But when it came to the physical reality of the place, like flooding, the problem with Google is their river was going uphill, down. It was absolutely not responding to real topography, which is not a detail. If you're actually going to try and displace population, rearrange cities, I mean, you have to act consequently on certain truths. So I'm answering your question sideways. What I'm saying is Google is probably the model of the future. If any big enterprise is going to develop further, I don't know what's going to happen to Apple. It maybe end up like IBM, sort of disappearing into thin air. But I think the Google model, this notion of informing through points of information, forming a base, is absolutely going to develop and continue. Whether Google is able to go into the level of resolution that I showed here, that would be a phenomenal task to achieve. It would be really phenomenal. But who knows? Maybe that will happen. I tend to think that it's more going to be a patchy thing. I think cities are going to have a model where certain areas will be very, very dense in levels of informations and levels of readings, and others will be very thin. So I don't think it's going to be that. I don't think it's going to be that systematic. The progress that's happening. But I think as a base, at least in terms of design and geographic information, I think we're going to leave the 2D not behind. We're going to keep it in the drawer. Those layered plans that we have, these analytical plans, the ArcInfo, all those ecological plans that we have. The mesh is also going to be kept in a drawer, and I think this conversion, this transformation to point clouds, this sort of mattress points, you know how they function, point clouds. I mean, each pixel hangs on 7 satellites. It's very precisely riveted, triangulated into position. I think that's going to become a very interesting model for the future. You know? And I think that's where things are going to build up.
I guess my real question is, what if this technology becomes commonplace?
It is going to become open source commonplace.
Exactly, but so there's a danger of being exploited.
But there's also a possibility of empowerment, depending on which way you look at it.
Yeah.
I'm taking the opposite. I'm saying at least the Indonesians felt like they immediately wanted to know how to do that. For them, it was because to get any kind of data, you have to give envelopes left, right, and center. Really complicated stuff, and you don't even know what you're buying, basically. So I think that this sort of bottom-up reality is an interesting case in point. And you may have parallel point cloud models of the same place. Who knows? But it is also a tricky question because it's really highly precise stuff. So there is a danger. There is a danger of real misuse. I don't want to over-dramatize that. It's a military position. It's highly precise stuff. So, it's not yet solved, right?
Going on from that, you're talking about the future of the technology, and I was wondering at the moment where you're dealing with capturing imagery using light waves, is there anything that you see in the future use of this technology that might be capturing the non-visible, like looking at infrared or methane emissions or something, and like the ability to continue doing some of these flyovers at a very large scale, whether that is possible, if you could start to actually visualize what's happening within the territory between the Earth and the image taker, and is that part of what they see might be the future of this technology?
Oh, you can definitely.
You can do
use
that?
a lot of sensors. I mean, James Nelson in the lab has been flying drones. I don't know exactly what he's sniffing, but he's been sniffing things up there. There's one woman that just got funded by the Swiss National Science Foundation to simulate sound in point cloud mode. She's fascinated with sound. The only book that came out on sound, people talk about noise today, but the last book was sort of a hippie book called Soundscapes, where the guys in the 70s were admiring the sounds of the birds and the bees and I don't know what else. And nothing's been written since then. It really hasn't been at all developed. And if you go to different places, I just came back from Japan, the acoustic dimension in the landscape or in the cities is a fascinating thing. It's very different from place to place. Even New York, with its sirens and all the rest. I mean, there's really a branding, almost a sound branding, you could say, for different areas. And she's developing her doctoral work using point cloud models and simulating sound. For instance, she went to Ustare there and monitored the bell sound, and we mapped it in the valley. I didn't show everything there, but that's becoming a very interesting reality because you can very accurately measure then reverberation and phenomena like this. So I think it's opening up a whole ability potential that we haven't really thought of yet. But I have no vested interest. I don't have a company. I'm not selling my points. I'm not trying to make a point here. I'm just basically saying it's happening. Whether you want it or not, this evolution is actually occurring, and it's going to change our way of conceiving things and of developing scenarios.
As a continuation of my first question is that we have now achieved arrived at the time of big data. There's a real opportunity of integration in terms of automation in design, and we've already started doing that in design schools. But it also signifies a transformation of the role of designer. What does it mean to be a designer? How much authorship are given? Because there's a degree of control in the algorithms you create in terms of automated design process. And do you think the current institution structure is accommodating that future as the division of departments?
Ooh, that's a very political question. I I mean, since I'm teaching landscape architecture to architects, my answer would be, I don't see division. But if you see division, then those divisions are going to change. Definitely. Because I saw the signages between engineers and architects and planners. It's very interesting in this project to see how the competences actually interrelated and nurtured each other in this sort of loop. And I think we have to go back to much more common problem-solving approach. And I think the fascination about this one model being there, it's one base, being there where you can test a variety of things, is going to be conducive to this bringing together, rather than this separation. At least I'm fairly convinced about that. You're not? But I don't know about design automation. I mean, I don't know. I mean, we could try and redesign the rivers of Jakarta automatically, but I would fear the worst. I don't think that would work. The handwork comes in at one point or another.
Well, it's I've seen recent years lots of exploration, optimization, so even some genetic design, genetic algorithm designs, evolution and stuff. But also you are designing a system, but at some point you let go. The system you run instead of using the data.
Actually, I think this comes back to the very first question, which is like how the research and design process interface with each other. And I'm fascinated to hear your description of the map that then allows this future conversation to have, that the map allows judgment to occur. And I wonder if that's actually very different than the idea of automation that you're describing. In the interest of, I think I could keep asking you questions until there's one person left in the room, but I think, could I ask you one final question and then wrap up there? In a way that's slightly different than what you presented today. I know you've written in other places about the kind of conception of nature, not as a wilderness, not as something that's distinct from the city, but as something which sort of has a cultural value, and that in many ways this form of visualization is something that allows us to kind of reposition the way that we image and conceive of nature. So I'm just curious to hear a bit more about that in the context of Indonesia, because when we talk about the meanings of nature and culture, of course there are many possible interpretations of that, and I can't help but think of the way that images of nature are often associated with national identity. In the United States, let's say through the national park system, or in the last time you were at GSAPP, you talked about the kind of myth of Heidi and the Alps, and if we have this kind of burden of a kind of nationalist identity of nature, how then do you understand that in the context of Indonesia?
Wow. And we worked with Bogor, with the Agricultural University, so we got really drilled into what a pekarangang is. Pekarangang is this sort of garden, productive garden, very symbolic use of plants, returning to nature, a mixture of Islamic but also pre-Islamic beliefs in nature. It's a tricky thing. I mean, we use the advice of local people as to plant selection and how to organize things in there. There is something, in a way, you could criticize the designs that were showed in the sense that they're very traditional and almost conventional agricultural productive landscapes. They're not really reinventing things. But the problem that we have is this notion of the public park. It never really hit the Indonesian culture. It was never there. They have a very old tradition there, which is called the alun-alun. The alun-alun is a strange thing. It's almost come from the desert culture of the Middle East, where they would cut out a huge rectangle in the forest and make it absolutely flat and empty like sand, and then just plant 2 trees in the middle. And that's also where judgment was pronounced, a whole bunch of things, people hanged, terrible things and good things at the same time. Very symbolic space, the alun-alun. And I have to say, when I entered Indonesian culture, and that's why I'm very cautious here, I'm saying we have to give the tools to the local people, and they have to implement that language, whatever that language is, which is true to their beliefs and symbolic, aspirations. I can't just come in there and just pack in a thing and tell them that's what it is. So in a way, you have to read this a little bit critically. I like the way that you use the word nationalist. I mean, I've done a lot of research on that. This notion of a planet with 7 billion people. We're not heading, at least in my opinion, we're not really heading back to nature, to an original nature. And when you look at the whole ideological history behind that, it goes back. The notion of native, non-native has been very clearly coined in Germany in the 1930s. It's been very thoroughly researched, and it was strangely in a period where it wasn't only the plants that were coined as native, non-native, but also people, and basically everybody went through that filter. And what's remarkable is that the environmental movement remained uncritical of that selection, which was rather arbitrary, because I would tend to say, if you look at the culture of plants in Indonesia, most of the plants that feed the people were brought in from other parts of the world. They weren't native plants. They were plants able to bring feed people. So I think it's a very, very broad thing that you're touching on right there, which would require far deeper inquiry and research for coming up with clear results. I just don't think that we're in an age where we're really redesigning primeval jungle. We're basically still destroying it. That's basically what I'm seeing. I don't think we've ever been equipped culturally or even technically to design a piece of raw jungle. And in any case, it would not happen in a place like Jakarta. It couldn't. It would be plucked. It would be completely overused. So I think that we have to stay within reason there. I think architecture and landscape are part of one phenomenon, they're linked to sedentary existence, right? Sedentary living, dwelling. And dwelling generates, in a way, a sort of abrasiveness which is incompatible with pristine organic nature that you seem to be referring to.
I think that's a great place to end the conversation. Thank you so much.
Thank you.
Thanks.